Hello student, our topic is nucleophilic substitution reaction. In case of alkyl halide, this is our alkyl halide, typical alkyl halide, where X is considered as halogen. Now, if we consider a simplest alkyl halide, methyl halide, then as we know the X is halogen, and halogen is the most electronegative element of its period. Now shared pair of electron between this carbon and halogen is attracted more towards this halogen atom. That's why the partial negative charge appears on halogen atom, whereas partial positive charge appears on carbon atom. And that's why this bond is highly polarized. And after dissociation, we can get a free radical or a carbocation. If the cleavage between the carbon and halogen atom, if the cleavage is homolytic, then we can get the methyl free radical, and halogen with odd electron. Whereas in case of strong influence of attacking species, this will be heterolytic and we can get methyl carbocation and halogen atom with negative charge. This halogen atom is considered as nucleophile. And this carbocation is the simplest carbocation, like methyl carbocation. Now nucleophilic attack possible at this carbon atom. That's why the substitution reaction, the free radical substitution or the nucleophilic substitution, both are very easy in case of alkyl halides. But remember, in case of aryl halide, these reactions are not so easy because the resonance takes place in benzene ring. Now, there are two main types of nucleophilic substitution reaction. First, sn2 or nucleophilic substitution reaction bimolecular. If nucleophilic substitution reaction is bimolecular, then it is symbolized like sn2 reaction. If we have a nucleophile from NaOH, KOH or any other compound, OH minus is considered as a nucleophile which reacts with alkyl halide. Typical alkyl halide, methyl halide. Step 1 is the nucleophilic attack on alkyl halide, which converts into a product, nucleophilic substitution product. And This is the byproduct. This is our nucleophilic substitution product. This is our nucleophilic substitution product. But this reaction takes place without any intermediate. And inversion of configuration takes place in this reaction. What do you mean by inversion of configuration? If we have this type of configuration, the halogen atom reside outside this carbon atom or the right hand side of this carbon atom, in our product, nucleophile attacks on this species and we can get the substituent on the left hand side. Substituent get attached at the left hand side of carbon. That means if we have a chiral carbon or optically active alkyl halide, then if we have a dextrorotatory, we can get the levorotatory as the product of nucleophilic substitution reaction 2. That's why another example is if we have another alkyl halide like alkyl halide with different alkyl group like 2 degree alkyl halide or 3 degree alkyl halide, then due to steric hindrance, it is difficult to approach central carbon atom easily by any nucleophile. That's why the nucleophiles are unable to interact with the central carbon atom, and there is no nucleophilic substitution reaction takes place in this case. Now, let us consider the order of different alkyl halide involved in SN2 reaction. Methyl derivatives are easily taking part in the SN2 reaction. After that, 1 degree, then 2 degree, and 3 degree is almost 3 degree alkyl halides are almost impossible to substitute by nucleophiles or the suitable nucleophiles. That's why this order is applicable in case of SN2 reaction. But in case of SN1 reaction is the two-step mechanism is applicable for SN1 reaction. Nucleophilic substitution reaction 1. We have a 3 degree alkyl halide like this. Which initially this alkyl halide divided into two components or heterolytically divided into two components. This is 3 degree carbocation we can get, and as we know 3 degree carbocation is the most stable carbocation. Second step of this reaction is, remember, SN1 takes place in 2 steps. Step 2 is attack of nucleophile. Attack of nucleophile on carbocation. We got we got this type of product. This is the typical product of SN1 reaction. Remember, always remember that retention of configuration takes place in case of SN1 reaction, and this reaction is always completed in two steps. Step 1 is the formation of carbocation, and step 2 is the substitution with the help of nucleophile. But in case of this reaction, 3-degree carbocations or 3-degree alkyl halides are the most preferable reactant, because 3-degree carbocations are the most stable carbocations. That's why the order of SN1 reaction or SN1 substitution reaction is always considered as 3-degree alkyl halides are the most preferable reactant, whereas 2-degree, now 1-degree, and ultimately methyl halides are the least impotent or the least attacked by the nucleophiles in case of SN1 mechanism. That's all about the SN1 and SN2 mechanism. Thank you everyone. Please subscribe our channel. We can make so many videos or useful videos on different topics of chemistry. Thank you.